Hi. Now in this tutorial what I want to do is show you how we can use these compound angle formulae to work out the sine, cos or tan of particular angles, which are combinations of 30, 60 and 45 degrees. And we do this by using the familiar trig ratios that you should know from the 30, 60, 90 degree triangle and the 45, 45, 90 degree triangle. If you're not familiar with these, just check that out on the website under trig ratios. Now, if we know the trig ratios then for 30, 60 and 45 degrees, we could work out the sine, cos or tan, for instance, of say 15 degrees, because we can think of 15 degrees as made up of the combination of 45 degrees minus 30 degrees. So if it was say the sine of 15 degrees that we were looking for, we could use the identity the sine of A minus B, where A would be the 45 degrees and B would be the 30 degrees. I'll show you how this works in a moment with an example. Another common angle that you could find in exercises is 105 degrees. What do you think that is? Well, it's 60 degrees plus 45 degrees. So again, if we had to find, say, the sine, tan or cos of 105 degrees, we could use the appropriate formula with an A plus a B. Okay, well let's just turn our attention then to doing an example. Let's suppose we had to work out the cosine of 75 degrees. How can we get 75 degrees out of these angles? Easy. It's going to be the cosine of 45 degrees plus 30 degrees. So A is the 45, B is the 30 degrees. So when it comes to the appropriate formula, we're going to take the cosine of A plus B, which is cos A cos B minus sine A sine B. So we have the cosine of A, that's 45 degrees, multiplied by the cosine of B, that's the 30 degrees, minus the opposite sign here, sine of 45 degrees, sine of A, and then sine of B, sine of 30 degrees. Now we can use our triangles because we're going to go for the exact value. So when it comes to the cosine of 45 degrees, that's adjacent over hypotenuse. So if we take this 45, the 1 is the adjacent, the hypotenuse is the root 2. So we have 1 over root 2. And we multiply this with the cosine of 30 degrees. So again, adjacent over hypotenuse means we have root 3 over the 2. So that's being multiplied by root 3 over 2. Minus sine of 45. If we take this 45, sine is opposite over hypotenuse, 1 over root 2. So we've got 1 over root 2 again. And that's being multiplied by the sine of 30, which is the opposite side over the hypotenuse, 1 over 2, a half. So if we now multiply this, we get root 3 over 2 root 2, and here we have 1 over 2 root 2. So we can put it all over a common denominator of 2 root 2, and we've got root 3 minus 1. And you could leave it like that, or you could decide to rationalize this by multiplying top and bottom by root 2. So this gives us root 2 times root 3, which is root 6, and minus 1 times root 2, which is root 2. But I'm not going to expand it. I'm just going to leave it then as root 2 on the outside of root 3 minus 1, and all of that is divided by 2 root 2 times root 2, which is going to be 4. Okay, so that gives us the exact value of the cosine of 75 degrees. Now if it had been the sine of 75 or the tan of 75 degrees, we would use the appropriate formula, but do much the same kind of thing. Okay, here's an example I'd like you to try. It's quite tricky though. See if you can find the exact value of the sine of 165 degrees. Okay, if you had a go, let's see how you got on. First of all, how are we going to get 165 degrees out of these angles, 30, 60s and 45s? Well, what we could do is think of this as the sine of 120 degrees plus 45 degrees. Now, did you pick 120 degrees? Maybe not. 120 degrees, though, is based on the 60 degrees, as you'll see in a moment. This is our A, this is our B, and we're going to use the sine of A plus B up here. Sine of A plus B is sine A cos B plus sine B cos A. So this is going to be the sine of 120 degrees, sine A, times cos B, cosine of 45 degrees. Then we have plus sine B cos A, sine of 45 degrees, and then cosine of 120 degrees. Okay, now, so how can we get the sine of 120 degrees and the cosine of 120 degrees? Well, this is the good bit. What you could do is use the quadrant method, or you could draw the sine and cosine graphs, but I prefer to use the quadrant method. It's a lot quicker. Remember, with the quadrant method, if you're unfamiliar with this, just look this up on the website. But we take our quadrants, 0 degrees, then we go 90, 180, 270 back to 360 degrees. And when we're dealing with 120 degrees, that's in the second quadrant, 90 to 180. So draw your line from here out to 120 degrees and complete the triangle. So you've got this angle in here is a turn of 120 degrees. And that leaves us with an angle in here of 60 degrees. Remember, making up the 180 degrees. So we're left with an angle of 60 degrees. So when it comes to doing the sine of 120 degrees, we work off this triangle here, which would be the opposite over the hypotenuse. And we got the same trig ratio here, okay, as we would have up here. This side would be the 2, this would be 1, and this would be root 3. It's not drawn to scale, but there you go. So the sine of 60 degrees, same as the sine of 120 degrees, would be opposite over hypotenuse, root 3 over 2. So put that in there. Cosine of 45 degrees, that's okay. Cosine adjacent over hypotenuse, so it's 1 over root 2. Then we've got the plus, and sine of 45 degrees, that's going to be opposite over hypotenuse, 1 over root 2. But this is the next tricky bit. Cosine 120 degrees. Cosine 120 degrees is not quite the same as doing the cosine of 60 degrees. Because when you're in the second quadrant here, when you're between 90 and 180 degrees, cosine is negative. Do you remember your quadrants? All, sine, tan, cos gave the positive trig ratio. So in this quadrant, cosine is negative. Got to remember that. So the cosine of 120 is the same as minus the cosine of 60. And the cosine of 60, adjacent over hypotenuse, is a half. So we have here minus a half. And that's where I feel a lot of people are going to trip up. So take care. Well, the rest is just downhill now, hopefully. Just multiply this out and you've got root 3 over 2 root 2. And as for this term, you've got minus 1 over 2 root 2. And we could put this over a common denominator just like we did in this last example, and that would be over 2 root 2, giving us root 3 minus 1. And it's funny how this has come out to exactly the same as this version. Okay, so we could rationalize it and get this answer, or just leave it as it is. But I hope that's given you some idea of how you can tackle these slightly more awkward angles like the 120 degrees. Okay, well that brings us now to the end of this tutorial.